how to apply the implicit differentiation technique. For any given implicit equation, we can follow the steps of the implicit differentiation techniques. So what are the steps of the implicit differentiation technique? The first step is to, for any given implicit equation, try to differentiate both sides of that equation with respect to x. And when you do that, the second step is just solve for y prime. So after following these two steps, you will be able to find the derivative of y with respect to x by using the implicit differentiation. So let's see an example. So let's say we have given an implicit equation as x square plus y square equal to 4, and our goal is to find the y prime or derivative of y with respect to x. So let's follow the first step. So to do that, let's write down the implicit equation, and the first step is differentiate both sides of this equation with respect to x, right? So let's differentiate x square with respect to x. Let's differentiate y square with respect to x, and let's differentiate 4 with respect to x. Alright, so what is the derivative of x square with respect to x? 2x, right? So we can write that down. And what is the derivative of y square with respect to x? So see the difference here. The y is actually a function of x, so it is not just some we are differentiating with respect to y variable, but y is a function of x and we are differentiating with respect to x. So it looks like a function raised to the power something. So we need to actually use the generalized power rule, which is bring the power down, so write down 2, right? So bring the power down, so write down 2, and then write down the function as it is. So y is as it is times derivative of y with respect to x. So this is the derivative of y square with respect to x. Again, so since y is a function of x, so we have a situation like some function raised to the power something, so we can use the chain rule, or you can say the generalized power rule precisely we can use, which is bring the power down, write down the function as it is, subtract the power by 1, so 2 minus 1 will be 1, right? So that's why we have 2y times, because of the chain rule we need to multiply by the derivative of y with respect to x, so that's why we have y prime, and is equal to derivative of the constant with respect to x will be 0, so that's why derivative of the 4 with respect to x will be 0. So this is the first step. We differentiate both sides of the implicit equation with respect to x. Now we need to follow the second step, which is we need to solve for y prime. Well, how can we solve for y prime? We need to isolate y prime, right? And so to do that, let's move all of the remaining term on the other side. So how can we move 2x? We can subtract 2x on the both side, and we get 2y times y prime is equal to minus 2x. So we subtract 2x on the both side, and this is what we get. Now how can you make to y prime alone? We need to divide by 2y on the both side, or you can say multiply by the reciprocal of 2y on the both sides. So when we do that, we get y prime is equal to negative 2x over 2y. So this is the y prime for this implicit equation. If you want to simplify or rewrite this, we can take the we can cancel out the common factor, and this can be written as y prime equal to negative x over y, and that is the required derivative of y with respect to x, or y prime, for that implicit equation.